Hello and welcome to the 4.5 notes. This is a section over a topic called linearization. And so what I want to do is kind of jump in here. And this is, linearization is a method to approximate function values. Okay. And when I say approximate function values, that means y values. Okay. So what I want to do is talk to you guys about kind of the concept of linearization. Let's say that I have a graph here, an x-axis and a y-axis, and let's say that I just have some curvy function here, f. Okay, and what I want to do, let's say that I know that this is the value, say 1, okay, x value of 1, and then this value right here is the y value, say f of 1, okay. Now what linearization does is it allows us to, our goal here is to approximate say f of 1.1, okay? Now let's say that we're able to calculate f of 1 and we're able to do that pretty easily, but what I'm curious about is what happens when I try to approximate 1.1, okay, which is this point right here. Okay, now what I want to do, a method that we've kind of discovered is using tangent lines, okay? So let's say that I drew a tangent line here at the point 1, okay? And, it's kind of a reasonable tangent line, but, this equation is in the form of y equals mx plus b, okay? The math that we could use, we're able to kind of calculate values on a line much easier than we are on some just arbitrary function. So the idea, okay, of a linear approximation is to, instead of actually calculating what the y value is here of f of 1.1, okay, plugging in 1.1 into my function, we can get a reasonable approximation if I plug in 1.1, y of 1.1, into our tangent line at 1, okay? So that's our slope m times 1.1 plus b, okay? So what this does, okay, this is a method to approximate function values, okay? And what I want to say is that, some conclusion that we draw here is that we use tangent lines to approximate the y values on a function. Okay? So it's a pretty useful tool. This is pretty basic as far as, approximating y values. So, and let me kind of come in here and draw in a y value here at 1.1. Okay, and you can see that these y values are pretty close to each other. They're not too far away. Okay, so we're just approximating them. So, you have this notation here where that a function evaluated at some x value is approximately equal to the linearization where you take f of a plus f prime of a times x minus a, yada, yada, yada. Okay, basically the way that I write this is if you wanted to find the linear approximation at x, okay, at some x value, that the linear approximation of x is equal to, at whatever x value, you take f of a, which is your, say, y sub 1, plus your slope m, times x minus x sub 1, okay? And so that's the way that we do it. And so that's kind of the notation that I will use as opposed to what they use here. Okay, so I'm just going to give you an example of this function x squared. Okay, and so let's just go ahead and let's just graph this function here of x squared. And I know that this is a parabola that has the point 1, 1 on it. Okay, and it goes up this way as well. Okay, and I know I have this point 1, 1 on my function. But I want to actually calculate the value of, say, 1.01. Okay, and I want to find that y value on this function. But what I want to do is use a linear approximation to find an approximation for that value of 1.01, okay? And so what I want to do is, let's first write an equation for our tangent line at x equals 1, okay? So part A, if we're trying to write the equation of a tangent line, remember we need an x value, which is 1. We need a y value, okay? And so I know that if we plug in, say, 1 into our function, 1 squared is just going to give us 1, okay? Now we need a slope here, okay? A slope at 1, okay? And the slope of the tangent line. Now the slope is equal to f prime of 1, all right? So I want to take my derivative and plug in 1. And so we're going to get, let me go ahead and do that here real quick. If I take f of x is equal to x squared, okay, then f prime of x is just going to be 2x. So f prime of 1 is just 2 times 1, which gives me 2. Okay, so my slope here is equal to 2. Now, if I wrote an equation of the tangent line, I'm going to use point slope form. I'm going to say y minus y sub 1, which is 1, is equal to our slope 2 times x minus x sub 1, which is our x value of 1. Okay, so then if I were to kind of solve this for y, I'd get y is equal to 1 plus 2 times the quantity x minus 1. All right, and so the idea now is that I want to use my answer to find an approximation for f of 1.1. So in part B, I just want to approximate f of 1.01. And so I would say that that is approximately equal to me taking, finding y of 1.01 from my linear approximation here, okay? And so if I plug that in, I'm just going to get 1 plus 2 times, and I'm going to plug this in for x. This is my x value. 1.01 minus 1, okay? And so now I'm going to take 1 plus 2 times, and if I take 1.01 minus 1, I just get 0.01. Now this is some math that I'm able to do, and so if I were to take 2 times 0.01, that's just going to give me 1 plus 0.02. So I get the value of 1.02, and that's what I'm looking for, okay? So I can say that, well, I don't know how to exactly do this to approximate that value, or to actually plug that in and multiply it by itself and get that value, but I know that I'm close to approximately 1.02, all right? So if I come back over here and use my equation of the tangent line, okay, let me draw that in. Okay, I'm not, if I zoom in on here, I'm not exactly touching this point here on the graph. I've got some distance here that I need to kind of clear up. Okay, but I do know that the point here on the graph, on this blue line, is 1.02. Okay, now let's actually calculate f of 1.01, and let's see how close we get. So if I were to actually calculate f of 1.01, then that's just going to give me 1.01 quantity squared, which is going to be 1.0201, okay? And these are close, okay? These are very close, okay? Obviously, the further away you get on your tangent line, okay, the worse your approximation is going to be. But if you can use that tangent line to kind of figure out what that is, okay? Let's jump down to the next one. And so this, on the first one it was a little bit easier because it was a function that we know. On something like this, we don't know how to evaluate sine functions, like a trig function, at 0.75, okay? We can use radian values, but we don't, know decimals, okay? And that's kind of the point of this. So the first thing in part A, it says write an equation line that represents the linear approximation of the following functions at the given point A. So what I want to do, let me just go ahead and graph it so that we kind of have an idea of what's going on. This is my x-axis, this is my y-axis, and sine of x, and I'm going to put pi, over 2, and then here I'm going to put pi over 4, okay? And so I know that if I plug in pi over 2, I'm going to get 1. If I plug in pi, I'm going to get 0. And so we get this curve, the sine curve like that. But what we want to do is, I've got the point pi over 4. I know my y value here is going to be the square root of 2 over 2. Okay, and so let me come in here and let me kind of just draw a tangent line here at that point. And we want to figure out, well, what's the approximation at 0.75? Now, it's important to note in this that pi over 4, okay, pi over 4 is approximately 0.785. Okay, so if we want to approximate 0.75, that's going to be over here. That's right about here. That's about 0.75. So what I want to do is I want to use my linear approximation to kind of see how close we can get to our actual value. Okay, so I'm going to write the equation of a tangent line here. And so let's do this. I know that I have the point, so in part A, let's write the equation of a tangent line. I have my x value of pi over 4. Okay, I have my y value of the square root of 2 over 2. Okay, I just need my slope. Okay, and my slope is equal to f prime of pi over 4. So if f of x is equal to sine of x, then I know that f prime of x is equal to cosine of x. And so what I want to do is find f prime of pi over 4, which gives me, cosine of pi over 4, which is going to give me just the square root of 2 over 2. So I have my x value, I have my y value, and I just need to find my slope, which is equal to actually just the square root of 2 over 2. So if I plug all this back into my the equation of a line, I'm going to get y minus y sub 1, which is the square root of 2 over 2. And that's equal to the square root of 2 over 2 times x minus pi over 4. Okay? And so what we're able to do now, and I can do this, I can say y is equal to positive square root of 2 over 2 plus the square root of 2 over 2 times x minus pi over 4. Okay? And so let's check and see what does it want me to do. Graph the function, linear approximation A. Use the linear approximation to estimate the given function value. So what I want to do is I want to say, well, I want to calculate an approximation for f of 0.75, okay? And so that is going to be approximately equal to the square root of 2 over 2 plus the square root of 2 over 2 times 0.75 minus pi over 4, okay? And let's go ahead and plug this into our calculator, and we're going to get about 0.682. Okay, once you plug that into your calculator, okay? And so, let's just think about this for a second. Let's actually find, say, sine of 0.75, and let's see what that is. Let me plug that into my calculator. And after I've calculated it, I get about 0.681. Okay, and so these numbers are very close. All right, and so that's the gist of it. All right, so hopefully this makes sense to you. What we're doing, and this is the big thing. Okay, we use tangent lines to approximate y values on a function. Okay, so go ahead and get started on the homework. I've got one more video that tells us about over approximations and under approximations. So stay tuned in for that. See you in a bit. Bye.